Hello, my name is Skylar Cardock and I am the Digital Marketing Manager at Wave. On behalf of Wave and Last Mile Gear, I am thrilled to welcome you to today's webinar with Positron Access Solutions. We specialize in connecting your customers to the internet. We pride ourselves on maintaining the most consistent stocking position in the market, and we also offer many value-added services, including technical support, staging and configuration, and training and events like this webinar. I am very excited to be here with Jim Stilley, the SVP of Positron Access Solutions, and Sandra Cohn, the Director of Marketing. Please type all your questions during the webinar into the chat and we will do a Q&A session at the end. I know everyone listening can benefit from extending gigabit fiber into your buildings, so without further ado, I will turn it over to Jim to introduce himself and kick things off.
Hi, folks. Nice to meet you all virtually. This is Jim Staley. My experience is with both Calix and Airspan Mimosa, so a little bit of wireless, a little bit of wireline, a little bit of fiber, a little bit of copper. And I came to work at Positron because I'm very excited about a market segment that has been abandoned by some of the telcos and made hard to penetrate by some of the cable companies. That's the MDU, MTU space. And what we have here at Positron is an alternative to rewiring, an alternative that provides the speeds that fiber optics provide without the expense of going to every door with fiber. So I'll be telling you a little bit about that. As Skylar noted, please feel free to send questions in as we go. We'll collect all those questions and try to answer them at the end of the presentation. There's about 30 to 40 slides. And I should be able to easily get through that and give you all time for questions and answers at the end. So the key takeaways will be first, then an overview, a very brief overview of Positron as a company. We've been around for 50 years. So we're very skilled at serving this market segment, wireless internet service providers, IOCs, LECs, and other segments of the telecom internet service provider sector. We'll talk about G.hn technology and overview. That's the technology we utilize to provide super high speed service inside MDUs and MTUs. We'll talk about the market segments where the product is best utilized. We'll talk about the portfolio itself. We'll provide some examples and talk about software a little bit, and then we'll go on to the questions and answers. So what I want you to take away from this presentation is that our solutions, starting with the G.hn Access Multiplexor, the GAM, allow a next generation of ISPs to immediately meet the needs of today's sophisticated subscribers and compete effectively in MDUs and MTUs. Our price performance convincingly beats other older copper and coaxial broadband technologies like DSL and G.fast, DOCSIS, and others, and it matches the performance of current fiber to the door technologies as long as symmetrical gigabit service to the subscriber is adequate. We can meet those needs. Our design is specifically tailored to meet the needs of MDUs and MTUs. We control our hardware, our software. We import components here to North America and then have integrated our own man-months of customization and security and so forth. It's a standard, and we'll go over that in a second, G.hn is, but we've highly customized it and enhanced it in order to be carrier class. Total cost of ownership of our solution, the GAM, is superior to rewiring with fiber or copper for Ethernet, say on Cat5, Cat6, or fiber. As I mentioned, Positron's been around for 50 years. We've developed and introduced solutions in North America for those entire 50 years. And our leaders are innovators in broadband, and our GAM specifically has garnered some good awards because of its innovative nature. G.hn is a standard, G.9660. It stands for Gigabit Home Networking. It was developed under the ITU. In its latest incarnation, it's evolved as has PON from BPON to GPON to next-gen GPON. And if you use wireless technologies, they've evolved and become more effective and efficient using less frequency spectrum for more bandwidth and so forth and so on. That's similar to how G.hn has evolved. G.hn leverages a non-blocking switched Ethernet core. So that means we effectively take bandwidth from your subscribers and feed it unblocked into your transport network. We'll talk about how that's done during the presentation. Every G.hn port on every multiplexer we make is 2 gigabits now. That's the latest incarnation of the G.hn chipsets. There's a future roadmap that includes 5 gigabits over copper twisted pair and 10 gigabits over coaxial facilities. And while we're delivering this 2 gigabit solution now, we can talk about that future technology for those of you who need to evolve to multi-gig per port solutions for your customers. We support some creative technologies and have implemented the premium versions of those technologies within our software at Positron, allowing for dynamic arbitration of upstream and downstream for a single subscriber or for many subscribers in a shelf, and for many subscribers in the case of coaxial splitters within a single port. The gigabit services work over existing telephone wire, Cat3, or coax of various types, and the installation and activation of these services is within hours as opposed to weeks when you try to go in and rewire a building and fish fiber or copper through the walls and drill holes and so forth. So that's the summary of what G.hn is, and I can answer more questions about it at the end of the presentation if you have them. This is how it fits in terms of comparison and contrast with other technologies. On this chart, I compare the GAM, our solution, with fixed wireless access, DOCSIS, DSL, G.fast, and the rewiring with Ethernet and optical. Notice that the GAM is up in the top right-hand corner of this chart. That's because it is both future-proof and cost-effective to the greatest extent. When you compare that against DOCSIS and DSL and G.fast, they're neither as future-proof nor as cost-effective as our solution because they're older technologies and they're limited with respect to bandwidth, rate reach, and symmetricality. Fixed wireless access, I've got the question mark on because it really depends on what flavor of fixed wireless access one prefers, but getting inside the building is difficult. When I worked with Airspan Mimosa, it was always pleasant to work outside with no trees. That always helps fixed wireless be effective. But inside a building, you don't have that situation. Lots of walls and so forth. Low frequency is low cost, very cost effective, but provides a low amount of bandwidth as it goes through the walls. High frequency, more sophisticated services that are licensed, they don't work well without line of sight, and they're also quite expensive. So that's why fixed wireless access is placed in various positions on this graph. Ethernet and optical are both almost as future-proof as the GAM. Ethernet specifically is almost, because it doesn't go as far. Even after you do all the rewiring and spend all the money to put Cat5 and Cat6 in, G.hn technology is going to go further and faster over Cat3, Cat4, Cat5, and Cat6 than Ethernet. And optical is the perfect solution if you've got the money. I always love service providers who provide optics all the way to the door for every one of their subscribers. The question is, when can it be afforded, and particularly inside buildings with large numbers of individual subscribers, when can it be afforded? So that's why optical is way far to the right with respect to future-proof, but not so high on the chart with respect to cost effectiveness. Some of our customers need to be convinced to go after the MDUs again. They've been abandoned, or they've been left to the cable companies, or a satellite dish on the ceiling plus some minor broadband internet coming through the building on existing wires. What this chart simply tries to show to service providers who are resisting to getting back into that market, it can be a very profitable market. Renters want broadband. MD owners want broadband. the owners of condos and townhomes and so forth, and business campuses want broadband, and operators can save 60 to 70% in terms of CapEx and lots of OpEx by using the GAM instead of rewiring. The next several charts provide rate reach for our G.hn GAM solution over both copper twisted pair and coax, just so you can see it. This is tested in the lab and in the field on Cat3 telephone wiring, 24 gauge. In this case, we provide gigabit services to 450 to 500 feet on a single pair and to 700 to 800 feet on a dual pair. The blue line represents single pair, that's called SISO mode, SISO, and the green star represents MIMO mode, multiple input, multiple output, or two pairs in every port. So any GAM port can support one pair or two pairs, and you can see that two pairs gets you longer distance. All those distances are longer and better than G.fast, which is the nearest comparable copper twisted pair technology. All those distances are greater than Ethernet, which can't work on Cat3. And when you go to Cat5, Cat6, we can go much further than 100 meters, even further than these stars represent, much better than Ethernet in terms of distance. With respect to cable TV, DOCSIS provides limited speeds over limited distances that are all shared, particularly upstream. So you can get a gigabit downstream. They'll sell you a gigabit downstream, but of course, in the afternoons and evenings when you're sharing that downstream with everybody else, you're probably not getting anywhere near that. And sometimes you're not even get what you need. And we know that most customers need, let's say, 50 megabits to be effective and be able to stream and play games and do emails and all that sort of thing simultaneously, much less if they're not. But what you'll notice, no matter what you're doing with cable companies, when the bandwidth is highly shared and highly in demand, is you're seeing very limited upstream speeds and somewhat limitation on the downstream speeds. We provide symmetrical services out to 1,000 feet on RG59, 2,500 feet on RG6, and 3,500 feet on RG11. So it beats DOCSIS in terms of symmetrical. It beats MoCA, beats any other technology over coax in terms of speed, symmetricality, and distance. So now that you know a little bit about how it works and what speeds it provides and how to use it on coax or copper, we want to talk about the market segments. We obviously specialize in inside buildings. That's where this wire exists. And whether it's a mid-rise or a high-rise or a garden-style apartment, our solution, our GAM, is perfect for those types of applications. We also are frequently used in mixed-use applications where the residents are on the top and the businesses are on the bottom, or in business campus applications. Because we've designed everything to be carrier class, we can provide service level agreements, and we've used Metro Ethernet Forum compliant components. And so there are many tier 1 carrier class ISPs using us today for business services, so in MTUs. Another specialty of ours is hospitality. Hotels and resorts of all types are using our product as hotels come out of COVID and try to serve their customers with the best possible entertainment and data services in their guest rooms without going through and remodeling all those rooms by, digging into the walls and having to repaint and do drywall work, etc. And then the technology is very scalable. Whether it's hundreds or even thousands of subscribers, it's cost effective. But it can scale down to, a cul-de-sac with 4 homes can be cost effective if a service provider has access to either the coax or the copper. We can work in those rural environments. While we specialize in inside multi-dwelling units, don't forget single-family homes if there's a challenge getting fiber to that home. This is a photo of both the coaxial GAM and the copper twisted pair GAM. The top one's coaxial with the F-type connectors. The bottom one is with the MIMO or SISO Ethernet connectors, so single pair or dual pair into any one of those ports. Notice that every GAM has SFP+, up to 10 gigabit, can be copper, fiber, active, passive, from a radio, whatever it takes. We're agnostic with respect to the transport. Just bring it into the 10 gig port. Give us 100 meg or give us a gig or give us 2.5 or 5 or 10 gigs. No matter to us. We will use that bandwidth and distribute it to each one of the G.hn ports, whether they're coax or copper twisted pair. Notice there's 2 SFP+ ports. That means the solution is highly scalable and stacks, and you can go in one SFP+ port and out the other SFP+ port and connect many GAM shelves together to provide service to many subscribers. I also mentioned that inside each one of these switches, it's essentially a carrier Ethernet switch core. And that's where we convert what you give us to G.hn and send it out on the ports. And then once we get to the other side of the equation, inside the customer's business or residential customer's unit or apartment or condo, we convert it back to Ethernet. Here's the entire portfolio on a single slide. Pretty simple, really. Indoor and outdoor. You see on the left, indoor GAM shelves, 24 and 12 ports, MIMO or coax. Stack them, rack them, whatever is comfortable. They're 19-inch standard rack mount with stackability with no gap between because the air vent's on the side. And then if you need IP68 outdoor applications, we've got the outdoor GAM picture there in the very center of the slide. We make that in, again, coaxial and copper twisted pair versions. That's the M MIMO. And we make it in 4-pair and 8-pair increments and various power options. So most of our solutions, you just plug them in. But we also have reverse power. We'll talk about that in a moment. We've got plus or minus 190 volts as well. So we're flexible with respect to power. On the right-hand side of the equation is what it all comes down to inside the unit. So essentially, the transport comes into a GAM. The GAM converts it to G.hn, sends it to the endpoint. The endpoint takes it in, converts it back to Ethernet, drops it off to a residential gateway or a Wi-Fi access point. An Ethernet switch, a radio, wherever you need the bandwidth, we're here to drop it off to you. A set-top box, for example, as well. So the endpoints are about the size of a deck of cards, pictured here, and they are coax or copper twisted pair, MIMO. And some of them are standard models. Some of them have VLAN trunking and 4,000 VLAN capabilities. Some of them are reverse power. That's the larger unit here. In case you don't have AC power, you can power one of these outdoor GAMs reverse power from the unit. Some of them provide PoE. Our newer units with the red stars indicate power over Ethernet. Both 802.3 AF and AT are supported. That's 15 watts and 30 watts. And so we can support those PoE applications, plug in the endpoints, and then provide power to another device within that room, and so on and so forth. So that's the entire portfolio, basically the GAMs and the endpoints. You'll need accessories like splitters for coax or filters or modulators, cable, miscellaneous cable and so forth, cable stubs, connectors, etc. But that pretty much end-to-end is the solution. And I'll show that to you in more detail in the following applications. So I think we're recording this and you'll be able to have access to this presentation afterwards. On each one of these application slides, you've got a title and a subtitle above there. You've got the network itself, starting with the data center on the left, transport in the middle, and the GAM and connections from the GAM and its endpoints on the right inside the MDU. You'll always have application notes telling you sort of what it's about and a legend to give you some a key around the lines and the colors and so forth. This particular application is 96 subscribers. That's 4 times 24 port GAMs, transport into one GAM, subtended, stacked to the second, third, and fourth GAMs. All the GAMs convert that transport into G.hn, put it out into each room where an endpoint converts it back to Ethernet and drops it off to a residential gateway. So just to keep it simple, this is the way every slide will look, and this happens to be a GAM MIMO 96 subscriber MDU application. The next slide shows a very similar application, except for instead of using the copper twisted pair within the building, we're using coax. An important advantage of coax, well, there are several advantages to coax. If the copper twisted pair Cat3 is not all that high quality, of course, or if it's disconnected and you can't make it from the MDF to the room, maybe you can use coax. Coax is a much better insulator, much more difficult to break, and coax uses splitters. Oftentimes, there'll be an MDF in the bottom floor of the building where the coax comes together, where the copper twisted pair comes together, and you'll see the coax attached to splitters, or you'll see one coax goes up to each floor and serves 4, 6, or 8 units. We support that architecture. We match the architecture of the coax throughout the building, whereas copper twisted pair is all home run. There should be a contiguous copper twisted pair from the MDF to the subscriber, whether it's an MDU or an MTU. Coax is more flexible because there may be splitters. When you're using splitters, of course, that means you're going to be serving more than one subscriber from each GAM port. So what we have in this case is transport into the GAM, just as with the other application. And then the GAM, each port may go to a splitter that's 2, 4, 6, 8, or even up to 16 subscribers supported. So that means 24 times 16, a single GAM shelf can serve 384 subscribers. Much less expensive per subscriber than a copper twisted pair application. And also, you'll want to keep in mind there'll be some oversubscription, right? Because you've got the 2 gigs. Actually, it's 1.7 gigs pure rate after you take the overhead out. So you've got 1.7 gigs to share amongst 1 or 2 or 4 or 6 or 8 or 16 subscribers on coax. With MIMO, it's always 1 for 1. And with coax, since you're sharing, you'll want to keep track of, what kind of service profiles you want to give every customer. The GAM can manage all the service profiles, the VLANs, the priorities, et cetera. And you will then decide if you're going to give 16 subscribers each their own gigabit. That's 16 gigabits over 1.7, which is about a 9-to-1 oversubscription ratio. Many service providers do that today because in actuality, those 16 subscribers are probably using about 50 meg each, which is about 300 meg, which doesn't even tax our 1.7 gig port bandwidth. And then we take all that bandwidth that they're using and we transfer it onto your transport link back to the internet. A few other applications I wanted to show you. Wanted to highlight the outdoor GAM on this picture. Assuming you have a doghouse on the end of the building, you don't have an MDF or an IDF to work with inside, the outdoor GAN can be really handy, whether it's in the copper twisted pair version or the coax version, whether it's AC powered, or in this case, we show reverse power, where each endpoint powers a port, and therefore you don't need to plug in the GAM8 MRX at the building. You just feed it with transport and run with it. Works exactly the same in terms of software and provisionality as the indoor model. It's just outdoor hardened with fewer ports. And it's especially helpful in those garden style apartments. Coax works the same. AC, or in this case, we're showing reverse power. One endpoint that's a CR, meaning reverse power for coax, on each port means that port is powered up. And each one of those ports supports splitters. So you could you could provide data up to 64 subscribers from a single 4-port GAM 4 CRX. Our product it's also flexible in terms of trunking. So you're going to bring transport in some cases, you're going to bring transport into every GAM on property. In other cases, you just can't do that. So we do drop and insert, both on copper, twisted pair, and coax. You can serve subscribers with some of the ports, and you can serve transport over the copper, twisted pair, or coax to the next GAM down the line, and so on and so forth, until you cover that campus. Even if you can't get your fiber or radio transport everywhere within the campus, we can get it there for you if you've got some buried copper, twisted pair, or coax. And here's the coax example. Just wanted to show one of those as well. You can, again, split out 3 ports for subscribers and use 8-to-1 split, that's 24 subscribers, or a 16-to-1 split, that's 48 subscribers within the building, and then use 1 port to provide 1.7 gig over coax buried in the campus to the next GAM down the line. We've used this, it's quite common. I think I've got a picture of it in trailer park or RV park applications as well, where you need it to be outdoor hardened, and you'll need to use the daisy chain capability to get to the next GAM down the line. We also use it to bridge the gap between the fiber and the building. So we've got business customers, we've got tier 1 business SLA customers who use the GAM, connect it to the fiber, extend the data into the building to other GAMs, which then serve the subscribers within the building, because there just wasn't time or money or permits done to get that fiber into the building. So you compete for business customers with SLA services, and then get some anchor customers and put the fiber in later. In this case, the GAM 8 MRX is placed in a pedestal outside the building, connected to fiber, and uses the copper twisted pair into that building. You can do the same with coax. And we use, with the copper twisted pair model, we've got a power injector so that we can power the unit in the pedestal, so there is no power needed there either. You can put it on a pole by the same token. This one happened to be in a pedestal. So extend fiber bandwidth into a building and build the fiber later, essentially. I mentioned PoE, and it can be done in a number of different ways. We can provide 802.3 AF with a power injector, and one of our units, you don't even have to plug in the endpoint. Simply provide the power to it, and it can provide power out to another device. But only Wi-Fi 5, 15.4 watt, 802.3 AF when there's a power injector involved. Without a power injector, you can use another model and just plug it in and then power out either the AF or AT, either Wi-Fi 5 or Wi-Fi 6, 15.4 watts or 30 watts. So we can provide the PoE, my apologies. We can provide the PoE then to external devices to make it's especially helpful in resort and hospitality applications where there aren't very many electrical outlets available. I mentioned RV parks and trailer parks, etc. We can use either the MIMO version, the copper twisted pair, or the coax version to extend service to snowbirds and other resort type situations where you want data and bandwidth to your guests for either a weekend or months while it's snowing up north. So that ends the application. There are other applications. I didn't want to go through too many, but there are other applications that we can talk about individually, or as you ask questions at the end of the presentation. I did want to spend a few minutes on software and how it works. What we've tried to do by making our product carrier class is provide all the subscriber management options you could ever wish for, because we know that ISPs each choose a way to manage their network, and we want to be flexible and fit into those. So with that, GAM solutions are enabled with our software team to do command line interface. So again, it's built on an Ethernet switch, so you can imagine what that looks like. It's got standard Ethernet router syntax, just like Cisco. but we've also got a web-based graphical user interface. Both of those solutions manage a single GAM and all subscribers from every port on that GAM. So you'll log into each GAM separately and manage all the subscribers in that particular situation. You can also treat us as a layer 2 bridge and simply manage those subscribers from the residential gateway. What we've done is we've made sure we're agnostic and work with every residential gateway out there. So if you've got a Calix-based one or Plume or Eero, whatever it happens to be, we interface with it. And if it's TR69, you can provision through us and just treat us as a bridge. We have not made an endpoint that has a built-in Wi-Fi radio because there are so many of them and they evolve so quickly from Wi-Fi 5 to Wi-Fi 6 to Wi-Fi 7 that what we plan to do is simply make sure that we've tested and we're agnostic to which one you decide to use or let your customers use from Best Buy, Walmart, or Target, for that matter. We are also building a multi-GAM network management system, element management system called Virtuoso. It's available to see today. We have it set up in our lab so you can see it manage multiple GAMs. It's read-only today, and you can test it for free. When we make it right version, that is where you can provision as well as see all the diagnostics for all kinds of GAMs, there will be a per subscriber fee for it then. The command line interface, the web-based graphical user interface are both free of charge. We also, if you're a service provider who's built your own back office already, we have JSON APIs and SNMP APIs, and that's free of charge. So we'll help you hook our system to your back office and manage it easily. If you use a partner already, whether it's RGNets or Sonar or ETI, we partner with those companies and more are on the way so that you can use their systems to manage our solution as well as your other solutions. The next few slides just show pictures of the command line interface, pictures of the web-based GUI with all the diagnostics and GAM access screen and service monitoring and port configuration. So this is all free of charge. Virtuoso, as I mentioned, is going to be a larger, more extensive element management system that manages multiple GAMs. There'll be a free read version and a per subscriber fee write version. And here's some pictures of it. It's very similar to the diagnostics, the screens that you see on our web-based GUI, except for instead of managing a single GAM, of course, it manages many GAMs. Then our partners can be found both on our partner page and within this presentation. And if you're using somebody like CDG or one of the others that you want us to integrate with, it only took these folks about 2 weeks to complete all the work to manage our system within their system. So that's pretty much it. Again, we want to allow you to immediately meet the needs of your sophisticated MDU and MTU subscribers. We'll beat everybody in terms of price performance, from the older copper technologies, the older coax technologies, to the fiber technologies in use today. And we'll beat other G.hn solutions because we, unlike them, bring all the components to North America, write all the software, put everything together, buy the mechanicals, make sure everything's integrated well. Some of our competitors just use an OEM line in China, bring it to the United States, paint their colors on it, and sell it as if it's theirs without any ability to fix bugs or modify software or make it a quality product or fix the security bugs and so forth. So that's what I want you to take away from this, as well as the fact that we can solve these problems. The cost, the speeds, the complexity, we make it so that you can avoid all those challenges. With that, I'd like to go ahead and thank you and invite questions if we have some. I'll try to answer them.
Awesome. Thanks for a great presentation, Jim, and thanks for sharing the GAM portfolio with us. We did have a few questions come in, and we will continue to answer your questions for the next as many minutes as it takes. So, Jim, the first question was, can we offer an IPTV service through the GAM?
Absolutely. So there are multiple video solutions that we support. IPTV is just one of them. We also support the combination of GAM data plus cable TV broadcast video, because we use the frequencies from 5 to 200 megahertz. Above 258 megahertz, you can insert channels. Now, this does not include DOCSIS, because DOCSIS doesn't work with anything. But if you're doing Dish or DirecTV, you can integrate those channels. We also support streaming, of course. So streaming, IPTV, broadcast video and frequencies above 258 megahertz are all supported. Any other questions?
The second question was, is there a cost for the software license or UI?
Excuse me. No, there's no cost for the built-in web GUI, the built-in craft interface port for Ethernet language scripts and so forth. We simply charge you for the hardware and you take care of the rest. There's no charge for JSON or SNMP. If you want to download that, we'll provide that for free. I don't know, there possibly is a charge for the hardware and or software from our partners, ETI, Sonar, CDG, RGNet, et cetera.
Nice. I do have a two-pronged question coming your way, Jim. On the coax version, how many subscribers can you use on a port using splitters? And can you use a standard splitter?
Good question. So up to 16 splits, it can be 1, 2, 3, 4, all the way up to 16. And you can use standard splitters. They need to be a more modern splitter. They need to be well connected. So you're going to need to do a site survey and just ensure that things are all connected up the way they should be. In the case of, if you're using reverse power, you'll want to use power passing splitters. We've got recommendations, and Wave has all the accessories. If they don't have them in stock, they can tell you what those accessories are. And there is a caveat that we don't use amplifiers. So if you're amplifying video and inserting it into our system, you need to do that amplification outside the G.hn coax and then insert it. We have ways though, even if you want to insert an amplifier mid-span, you basically just break out a little branch, amplify the video, and then bring it back into the same coax. So I think hope that answers that question.
It does. Two other questions came in, Jim. The first one is, can you define bandwidth profiles for different subscribers on the same unit? Yes,
absolutely. Every subscriber on every port. So in a MIMO situation, that's a one-to-one situation where you're going to have one port, one subscriber, and you'll use either your system, treat us as a layer 2 bridge and provision all the rate limiting and profiles through your system, or alternatively use the GAM to do it. We have that flexibility as well. And then on a coax system, you do the same thing, but it could be many subscribers per port, up to 16.
Awesome. And then the last question that came in for you, Jim, was, do we need to use any specific SFPs?
No, it's a standard-based non-keyed SFP slot, so you can use any SFP plus. Now, you can also get those from Wave, and you can get a recommendation from us because, as you can imagine, we've tested a whole bunch of SFP pluses in our labs, and some work better, some last longer than others. I would stay away from Ubiquiti, and MikroTik has some good ones and some bad ones, but there's a lot of quality SFP pluses out there you can use, and we don't restrict your usage.
Awesome. Well, this was a great webinar. Those were all the questions we had come in through the chat. If anyone has any additional questions, please reach out to either Wave or Last Mile Gear if you have a dedicated sales rep. If you would like to get connected with a dedicated sales rep, please email info@waveonline.com and we will get you connected and get your questions answered. I know I appreciate it. I'm sure on behalf of Jim and Positron, we all appreciate you attending this webinar today, and we look forward to being in touch with you and just want to thank you for your time. Any last words, Jim?
No, thank you very much for your time today. And we'll give you a little bit of time back to your day. And as Skylar mentioned, reach out to your account manager or find out who your account manager is at Wave, and then we'll be along for the ride. We'll make sure to help you be successful in deploying your first GAM in your first building.
Awesome. Thanks so much, everyone. Have a great day.